we are international people and Swedish people in the audience, and you are all very welcome to this seminar. It's about the borderland between steel and agriculture, and it's important because we need a lot of progress in agriculture, and there are a lot of solutions in the steel industry. This webinar is part of a research project called New Steel Structures for Agriculture. The aim is to increase the knowledge and interest in steel solutions. And we have focus on high-strength steel and wear-resistant steel. And we focus on agricultural segments. Who are we? We are AgTech 2030, which is an innovation platform, and Linköping University, Agroöst in Swedish. It's a network of farmers, and SSAB. So we are joining together for this. Some words about the innovation platform. It's a kind of cooperative effort, about 90 companies trying to improve innovation in agriculture. And the host of this is Linköping University. And we have about 45 different innovation projects, and this is one of these projects. We will be with you today, and who are we? You will get information about the persons as they are coming up here on stage. And I will begin with some introduction about challenges of agriculture and the role of steel. And how can we start this? First, we can go back in history. What was the main challenge in 1798? Thomas Malthus were very worried about how we can improve food production in relation to population growth. That was a main challenge for many people in that time. And we got a lot of progress thanks to steel tools. You can see here on the photograph some of those tools. And if we go to the 19th century, in general, about 4,200 minutes per ton harvested grain was the productivity. You can have that in mind, because if you look at this today, only 2 minutes. So Malthus, he was very worried, but we did solve the problem. And thanks to innovation in agriculture and including a lot of steel constructions, we really made it to feed the population. And if you look at in history a little bit more, here is Katarina Karlsson. She's a researcher, and she states that steel and agriculture are two areas very much connected. And if we look at the history, for example, the knife bar to cut the seeds or the grass, it's very important innovation in the progress of agriculture, and that is thanks to steel constructions. Another is shield plow to make hard and very good quality steel. That was a basis for many plow innovations, for example, cultivators. Here you can see a Väderstad harrow, and you can see there are square tubes involved here. And that was a really important innovation to integrate square tubes in agriculture machinery. And here is one of the companies, Stewart and Lloyd's in England, who provided such products very early. Here is a productivity of agriculture from 1950 to today, and you can see it is a progress of 2.5 times productivity. I can't see any other industry with that kind of great productivity. The problem is our challenges today. We need much more food in the coming years, but we also need to secure biodiversity and bring down emissions. And this is a really hard equation. So how can we solve this dilemma? We need innovation. And one problem is soil compaction. Sometimes compaction is good, but sometimes it's bad. And sometimes you need better machinery, effective machinery with lower weight, and smarter steel construction can bring down weight, and that can have a lot of good effects on harvest and also environmental things. One example of this was a cooperation between SSAB and John Deere. Some years ago, they decided to join forces, and it ended up in a header and also a cleaning show, and they brought down the weight about 30% or something, and they brought down the cost of production, and they also secured the stability of the construction. So sometimes you can achieve many goals at the same time. We need a lot of more innovations in agriculture. We need it for precision. This is a precision machine from the Nexat company, and you can see there are also Väderstone involved here. We need much more precision, and we need good quality, because that is connected with the progress and sustainability of agriculture. To conclude, we need new steel constructions and new steel qualities to prevent soil compaction in some cases, to achieve more stability and precision, and we need it for higher productivity, because we have a mission to feed the population in a sustainable way. By those words, I leave the words to you, and you will talk about what? Welcome.
So, thank you. My name is João Prechard. I am a design specialist. I work in SSAB, helping customers to upgrade their designs, their projects. I will start explaining a little bit about our steel families. We can say that we have two big families of steel, strong steels and hard steels. The strong family is made for structural applications, and it's called strengths. And the hard family, it's wear steels, and it's called hardox. When we are developing steels and we are trying to achieve higher yield strengths, we also are getting harder steels. So our structural steel is stronger, but at the same time has a higher hardness compared with mild steel. And our hardox is very hard, and also it has an inherent high yield strength. If we compare some metals like aluminum, mild steel, or high strength steel, we can see in strength we will have aluminum as a strength of 260 yield strength, and high strength steel strength 700 with 700 megapascal, and mild steel 250 or 350. And here we can see that those are the features that the designer is looking for when he is making a product. He is not looking for any other property. It's the yield strength that will help the designer to create the components. Talking about segments that we in SSAB have worked. We have worked a lot with road transport, lifting, agriculture, and other segments. But we need to say that road transport and lifting, they are a bit more in front of agriculture. We have seen much more applications in road transport and lifting than we have seen in agriculture. Here is an example, is a trailer. It's a grain stepper, double grain stepper, that was completely upgraded from mild steel to high strength steel. And here in this product, it was possible to reduce the weight in 2.3 tons. Meaning that when this product is loaded, it's possible to load 2.3 tons more of grains. And when the tipper is empty, it will save fuel. If we talk about agriculture, we know that in agriculture, size matters. And now we are talking about sprayers or combine machines, harvesting machines. As you can see in those two green fields, we can see that in the left, a smaller machine will cover that plantation in 4 rounds. If you look in the right side, we can see that a wider machine will cover the same plantation in 3 rounds, meaning that we will make the job faster, we will provide less soil compactation in this plantation here. And this is the idea to work in agriculture, to fight for wider machines, bigger machines, but not heavier machines. This is an example from South Africa. This is a air seeder machine. It was a finalist from the Swedish Steel Prize. At that time when it was released, it was the largest of its kind in Africa. It was possible to plant with this machine 5 hectares more per hour, and in the whole plantation season, it was possible to save 420 liters of diesel. So we can summarize the agriculture segment that the machines must be light. Must be light to avoid soil compactation. Future machines, electrical machines, must be light to avoid the weight problem, because they will need to have heavier batteries to work for more hours. Machines must be strong to work the whole season without some problems in the middle of the season. Machines must be stiff, because we know that in sprayers or harvesting machines, the stiffness of the arm of the sprayer is important to guarantee the same amount of spray over equally in the whole plantation. And in the end, we understand that machines must be cost effective, because the manufacturers must make money with those machines. So here we can see an example. It's a winch attached to a tractor. And here we can see both families of steels from SSAB in one product. The whole structure of this winch is made out of high-strength steel. And the red region is made out of hard ox in order to go into the soil without suffer abrasion. That one is another product, is a plow. And here all can see that we are using tubes, strength tubes in high-strength steel, square tubes 120 and 140 millimeters. And the arms connecting the structure to the plow is made in strengths 9 and 10 millimeters. Blades are made in boron steel. So as a summary, we can say that the properties in agriculture machine are connected. We have the weight, we have the strength of the component and the stiffness. In order to reduce the weight, we must make something to keep the component as strong as it was, as strong as it was. The only way to make this is increasing the yield strength of the material. The stiffness of the component is much more connected with the geometry, and here we can help the customer to try to design a strong component, light and stiff. One of common questions made for us is about the machinability of our products. And here we can see 2 of the most common structure steels, 700 and 960. And in the right side, you can see that the inner radius for bending is very tight, and also the carbon equivalent, meaning that it's a kind of steel that is possible to be welded.
My name is Jonas Adebert. I work as a wear specialist within SSAB. I will give a very short introduction to our wear steel for the agriculture segment. If we start with our latest product, Hardox 500 Tough, this is the next generation as a general wear plate, replacing the Hardox 450 grade. So what we have done on this product is that we have actually increased the hardness to 500 Brunel level, but keep the good properties that we had on Hardox 450 when it comes to workshop properties and when it comes to formability and the toughness and so on. If we start with looking at mechanical properties of this steel and compare it a little bit to Hardox 450 and Hardox 500. First of all, to the left, you can see the hardness of 500 tough is at 500 Brinell level. But also what is important here is that we have the tightest hardness interval on the market on this plate. And this is important because first of all, you will have a reliable service life of your equipment due to the hardness interval is so tight. But also when it comes to formability of the plate, the hardness of a material is related to the strength of the material. So when you form the plate or bend the plate, you will have a spring back due to the high strength of the material. But the closer the hardness interval, the more equal it will be from plate to plate if you have a tight hardness interval. If you look at toughness of the material to the right, you can see that we are on the same level as Hardox 450 when it comes to toughness. It's around 45 joules at minus 40 degrees Celsius. But what we also deliver on this material is that we have a toughness guarantee. So what we guarantee on this material as a wear-resistant steel is that all the material that we supply will have at least 27 joules at minus 20 degrees Celsius. And of course, this is important when it comes to crack resistance of the equipment. So a little bit about the workshop properties in the workshop. First of all, welding. Welding is important for our steel. And what we have tried to do is that we make this steel but with the same good properties in the workshop as a Hardox 450. So if you look at welding properties of Hardox 500 tough, you don't need to preheat, you don't need to change anything for material up to 16 millimeter of Hardox 500 tough. Above 16 millimeter thickness, we recommend a preheating temperature of 75 degrees, and that is not too high. And you don't need to change anything when it comes to welding consumable and so on, compared to Hardox 450. When it comes to forming, we have the exact same recommendations when it comes to Hardox 500 tough as for Hardox 450 when it comes to bending. So if you are using Hardox 450 today, you don't need to change anything on the drawings when it comes to Hardox 500 tough, when it comes to minimum radiuses. Of course, this material is a little bit harder, and that means a little bit higher strength. So that means that you will need a little bit higher force in the bending machine when you form the material. If we look a little bit about the wear resistance and compare it to Hardox 400 and 450 Brinell steel, what we see in increased wear resistance is, for example, for a granite rock that is quite common in the soil, we can see an increase of 35 to 40% increased service life compared to Hardox 450 or another 450 Brinell steel. If you compare it to a 400 Brinell steel, we can see almost the double of the service life for a granite. Dent resistance, a little bit about dent resistance, because this can be important when it comes to building tipper bodies or something like that. If you load tipper bodies with a big rock or something, you have a risk that you will cause a dent in the bottom of the tipper body. But dent resistance of a steel is related to the strength of the material. And in this case, this means that Hardox 500 tough will have much higher dent resistance compared to a Hardox 450. So what you can do is actually that you can reduce the thickness of the tipper bodies to save weight, but you can keep the dent resistance that you have on the tipper body, but with using thinner material. And this is also important even though you are loading grains or sand or something like that, because you can build a much more flexible equipment with this with Hardox 500 tough instead, because sometimes you can have a risk that you are carrying bigger rocks, or there is a big chunk there that is loaded in the tipper body. And with 500 tough, you reduce the risk that you cause dent in the tipper bodies. Of course, this means that we can produce much lighter equipment if you can reduce the thickness of the tipper bodies or the equipment in general with Hardox 500 tough compared to other wear-resistant steel. Very shortly about our newest grade when it comes to the Hardox family. This is Hardox High Ace. It's made for wear corrosive environment, and I think this is very interesting for the agriculture segment. This product was released or launched globally May or March 2020, so it's only 2 years old, this product. But we have already started to use this product in the agriculture segment, actually. And some of the areas that I think is very interesting for Hardox Highas is fertilizer handling, manure handling, slaughter waste, or other type of environment where you have low pH or you have chlorides or sulfates or something like that that is causing corrosion at the same time as you have a wear. And in this case, we have kept the good properties of Hardox 450. We have a toughness guarantee on this material as well. And the hardness level is on 450 Brinell. So that means that you will have the good wear resistance from Hardox 450, but we will also add the corrosive resistance on this material. And I have just one example here of where to use Hardox Highas. This is a mixing of manure in the agriculture segments. And here we compare it to stainless steel and Hardox 450. And as you can see, I mean, we have much longer service life, and that is due to the corrosive and wear resistant of this new material, Hardox Highas. So in this case, we have prolonged the service life much more compared to Hardox 450 and stainless steel, actually. So I think this is a very interesting material for the agriculture segment, where we can build equipment that can handle different type of environments.
Yes, then it's my turn here. And my name is Amanda. I work as a design specialist at SSAB together with Jonas and Joe. And I will talk a little bit about production efficiency according to upgrading to high-strength steel. But what do we mean when we talk about production efficiency? We have 4 different goals. We want to make less material, use less cutting, welding. We also want less parts to work with, so it's less to assemble. But we also want to increase something, and that is the payload. We want to increase the service life and want to make it more fuel efficient. And we also want to make it faster, like the assembling and the lead time to produce the products. And how do we come here? We want to improve our design and the logistic just to how we are going to upgrade it. So, what do we mean with upgrading? As you heard about Joe and from Jonas, we can talk about different kind of structures. And here we have 2 different I-beams. One in mild steel and one in high-strength steel. The left one is the mild steel and the right one is the high-strength steel. And as you can see, they have different kind of dimension, and the higher beam is both higher and thinner compared to the mild steel design. And as you can see, we have minimized the weight with almost 40%, which is really good when we're talking about upgrading. But still, we have a higher bending moment capacity for the high-strength steel. And we also can see that both less material, less welding, but the same cutting to produce this kind of structure. But it's not that simple, because we have to look at the whole design when we're talking about upgrading. And when we talk about production efficiency, we want to look at both designs and see how can we make this more easy to assemble and to produce. And here we have one design in mild steel, as you can see, to the left, and one in high-strength steel to the right. And we have almost 100 items for the mild steel and 15 items for the high-strength steel. And that is a lot different, which makes it more easy to produce the one in high-strength steel. And as you can see, both cutting, welding length, and the number of bending will be more than the half for the high-strength steel design. And in the middle here, you can see relative production cost. And as we all know, the high-strength steel will be more expensive to buy. But both the cutting, welding, and bending will make it up to that cost. So it will be more efficient to use the high-strength steel. And as you can see also, the weight saving will be around 72%, and the productivity saving will be 16%, which is really good when we're talking about production efficiency. Here we also have an upgraded example. We have the previous design, which has the weight of 1,335 kilogram, and we have the new design with high-strength steel, which has a lot less weight, which was 740 kilogram, which is really good. And also the number of items is a lot different between these two designs too. The cutting length is almost the same as the previous design, but the bending is more for the high-strength steel design, which you have to take in account when choosing what kind of design you want to use. The welding, though, is a lot less for the new design. And this is something to have in account when we're talking about upgrading to make it more efficient for each company. If we are working with welding, we want to use maybe more welding because that is most preferable for us. But we have to think in that way when we're making the new design.
Thank you, Amanda. I will give a very short introduction to the fossil-free steel that we are trying to produce right now at SSAB. I think most of you have heard about this. If you look a little bit on how we produce steel today, this is a 3,000 years old technique. We use a blast furnace, and what that do is that we reduce the iron ore and take away the oxygen from the iron ore, and by that we are using coke that is based on coal to take away the oxygen. And by this process we are actually by producing 1 kilogram of steel, we are releasing 2 kilograms of CO2 instead, and that is something that we are trying to take away with this new process. So if you compare it to the new process, what we want to do is that we want to use hydrogen instead of coke in the process to take away the oxygen from the iron ore. And what will come out after that is pure steel and also water instead of carbon dioxide. So this will be the new process that we are trying to do. And how will this be done? We are working close together with LKAB, the iron ore producer up in north of Sweden. We are working with Vattenfall to supply us with fossil-free electricity. And SSAB, we will produce the steel from this. And the plan is that 2026, we will have 1.2 million tons production of fossil-free steel. And the production plant will be up in north of Sweden in Gällivare. Right now we are running a pilot plant up outside Luleå, and things are looking really good right now. And also what is new here is that we are investing 45 billion Swedish SEK in 2 new steel plants in Luleå and in Rae for fossil-free steel that will be ready at 2030 actually. So that was a very short introduction to the fossil-free that we are having. Okay, then we have time for questions. I think we have one question is availability of Harox 500 Tough and Harox High Ace. We have availability on stock in Sweden on Harox 500 Tough and Harox High Ace. We also have a lot of local stocks around the world on Harox 500 Tough and Harox High Ace. So I don't think that will be a problem to get material. And I will see if we have some more questions. Thicknesses, when it comes to thickness of materials, we have, in general, you can say that we produce from 0.8 millimeter thickness up to 160 millimeters. So the dimension program that we have when it comes to thicknesses of steel is the best in the world, actually. So that will not be a problem either. We have one question about welding of hardox and to other steels. That is of course possible to weld hardox against mild steel or other type of steel without any special consumable or something like that. So it's very easy to weld hardox against other type of steels. And we have guidelines and recommendations on our homepage that you can download how to weld and what consumables we recommend. Let's see if we have a few more questions here. Something about increased service life when changing to hardox. That will depend on different things actually when it comes to increased service life. First of all, what type of aggregate are you handling? If it is granite or if it is soil or if it is sand or something, that will depend. That will influence the increased service life if you compare it to mild steel. But there is actually a quite easy tool to use here, and that is called WearCalc. That is a software tool that you can download on ssab.com as a customer and register for that. So in that software tool, you can calculate the increased service life for all the hardox grades compared to mild steel, for example, for different type of aggregates like sand or granite or other type of abrasive material. We have one question about bending instead of welding, and I think I will leave that question for Joao here.
Yes, why we always recommend to make bendings instead of welding. When we are bending the material, we are not changing the structure of the material. As we have worked a lot in this structure in our steel mill. So the bending will keep the structure in the material as it is. It will keep the hardness, it will keep the strength as it was made in SSAB. And this is why we try to keep the material as it was. Of course, we know that it's possible to weld the material. It's not, we can weld, but always as possible is better to bend.
Is there something special you should consider when forming hardox or strength compared to mild steel?
Always we must take care about the bending radius. While bending hardox or strengths. We in SSAB, we can guarantee some bending radius for all grades of hardox and all grades of strengths. If the customer follow this bending radius, it's possible to make the bending without any risk. Perhaps what about combination?
And then we have a question about what about combinations of steel and composites in agriculture machinery. The mixing steel and composites is of course possible. I think the tricky part here is to attach them to each other, because welding is probably not possible, but bolting or something could be definitely a possibility. And I think that is something that we should work much more with in the future as well, to combine different type of material to have the optimal solution in different applications.
Yes, indeed. The joining, it will be the big challenge. And then we need to think about rivets, bolts, some kind of joining that it's not welding. Jonas, perhaps you can explain how it's possible to affect the bending radius. What are the dimensions we need to take care in the bending machine?
Yeah, when it comes to bending, our recommendations are based on thickness of material. So usually we supply a bending recommendations that is based on the radius over thickness. So that is the thicker the material is, the bigger the radius needs to be, of course. And also what you need to consider is the spring back of the material. When you bend high strength steel, you will have a much bigger spring back in the material instead compared to mild steel.
And now we got the golden question. We were sure that this question would come, and it arrived. And the question is, what about weight? Because there is a true in the agriculture sector is that we need weight. We need weight to make this machine go into the soil. So why should we remove the weight of this machine? But now our comment is that if you need weight, why not make a wider machine that it will weigh more? You will have the weight that you need, but with more lines in the machine. So this is our thinking about weight.
Yeah. And also I think it's a matter of thinking with the design and so on. How can we design the ground engaging tools so that they are more effective, even though the equipment is much lighter instead? So it's a matter of thinking in a new way to have a more efficient machine. And then we have a question: when is the Hardox Galvan coating coming? That is a good question, and as to my knowledge, we are not trying to develop a Galvan material today. I think the Hardox Highas is a brilliant example of how we are trying to develop new materials to be able to fit in new segments and in new applications and to solve problems that we have. And I think Hardox Highas has a very good position when it comes to wear corrosion issues in different applications. And then we have one question here: what is your recommendations regarding preheat temperature when welding strength 700 MC?
Strength 700 is a very friendly material to be welded. It does not require any special care. If we are talking up to from 1 millimeter to 25 millimeters to 1 inch. After 1 inch, it's necessary some preheating that we have in all our handbooks. We have the welding handbook, we have the design handbook, and so as we believe that anyone will use over 25 millimeters in agriculture machines, there is no special need. There is no need to use special wires, filler metal. The customer can keep using the current filler metal, so it's not a hard material to work.
And we have local technical support in more or less all countries in the world to be able to support for specific questions on welding, forming, and so on. And then we have specialized people that is only working on welding or something else. So if you have some specific questions on welding and so on, you can definitely get back to SSAB.
Question about tubes. Yes, we have. We have a facility that just makes tubes in high-strength steel. This facility is located in Finland, and we have round tubes, rectangular, and square tubes. We have tubes in 700 megapascal, 960 megapascal. The dimensions range is from 40 millimeters to 300 millimeters. And we know that the agricultural market has lots of tubes. So we have the tubes.
Yeah. And also we actually have some Hardox tubes for wear resistant applications. So Hardox 400 and Hardox 500 is actually possible to get as a tube. We have one more question. If you say that Hardox 450 is replaced with Hardox 500 Tough, then is the 450 not produced anymore? Of course, we will produce Hardox 450 in the future as well. That is, of course, the case. But we are believing that the market is moving to 500 Tough instead, because you can use Hardox 500 Tough instead of a Hardox 450. And by that, you can reduce the weight or you can prolong the service life. So there is, how to say that? I mean, the materials can be used in the same applications. So I think Hardox 500 Tough is the future when it comes to wear resistant material. But of course, we will have Hardox 450 produced in the future as well.
Another question we received now is that the customer would like to make a tipper to work with fertilizer or something acid. Which material this customer should use, Hardox High Ace or Hardox 500 Tough?
Sorry.
The tipper is made for acid environment.
Yeah.
The customer would like to know if the material, the right choice is Hardox High Ace or 500 Tough.
Yeah, for acid environments, we recommend you to use Hardox High Ace because that one will resist both corrosion and wear at the same time. The tricky part when it comes to corrosion and wear working at the same time is to understand how much wear do you have and how much corrosion do you have when you are when you're using the equipment. So by using Hardox High Ace, I think we have a much better possibility to really optimize the equipment. We have one more question here. It's in Swedish. I will try to translate it. Do you have any easy comparison what in strength, thickness, ordinary steel versus strength? So can you compare a thickness of strength to related to a mild steel?
Easy. Actually, is not so clear the answer, but we can say it will depend on the application. If you have a very simple application like this component here, and we have this component made with some material like 350 megapascal, and now we will change this yield strength from 700, it means that this component will hold twice the load. But in reality, things are not so easy because sometimes instead of this material, we will have the arm of the sprayer. And then we have tubes, we have welding in the tubes, we will have fatigue issues. So it's not so easy. We have by our experience, when we are upgrading structures, components from 350 to 700, we have by experience that we can have around 20-25% from the weight. But it will depend on the application. Yes.
But when it comes to fatigue, is this something that you support with to help our customers with
yes,
when they are upgrading?
We have a department here in Sweden that works with design. We have another group that works with wear, and we have another group that works with manufacturing. So all customers that have some questions regarding design can ask us regarding wear, what about the best material for this application, and regarding manufacturing can send questions for us.
Good. I think time is up, more or less. We are 2 minutes after time. So I think that was all the questions. But if you have more questions, something, you are more than pleased to get back to us and we will try to answer them afterwards. Thank you very much for taking your time and look at this.